Hello viewers, welcome to the session on ECLAT Algorithm in Machine Learning. Please make sure to watch all the prerequisite videos for your clear understanding and to make best use of it. Firstly, let's look at the definition of ECLAT algorithm. First of all, the word ECLAT stands for Equivalence Class Clustering and Bottom-up Lattice Traversal. The name itself suggests the working of this algorithm, and moreover, it is one of the popular methods of association rule mining, and it is a more efficient and scalable version of a priori algorithm. While the a priori algorithm works in a horizontal sense, imitating the breadth-first search of a graph, the ECLAT algorithm works in a vertical manner, just like the depth-first search of a graph. This vertical approach of the ECLAT algorithm makes it faster algorithm than the a priori algorithm. Let's visualize the same thing so that you can understand it in a much better way. Before moving ahead, the components that we are going to use here is same as what we have done in a priori algorithm. That is, they are support, confidence and lift. I would request you to kindly visit the a priori algorithm if you are unaware of these terms. So now let's understand both a priori and ECLAT algorithm more visually. So in a priori algorithm, we were using breadth first search technique, which means we were going level by level. After completing each level, then only we were going to next level. Here the each level represents the k item set. That is, it is one item set, this is two item set, three item set, like that goes on. And here we were going one after the another node in the same level. After completing each level, then only we were moving to the next step. Let us suppose that our item was somewhere here. Then in a priori algorithm, we were traveling from A to B to C, D, E, F, G, H, then we were coming to I. Whereas in ECLAT algorithm, we were using depth first search, which means here the backtracking concept can be utilized, which means from the starting root node we go to the leaf node. If anything was found earlier only, then we used to return the same thing. If it was not found, then we used to go back and do the backtracking and return to the next element, and we will go on keep searching the same item. Let us consider the same example that we have taken in a priori algorithm, that is considering the I as our search element. Let us suppose the I as the search element. Here the search technique is very fast. You can see that from A to B we go to B, then we were just passing to the next level without completing that particular level. See, from A to B, then we were going from B to D, D to H. H was not the item, so we went back to backtracking to B. What was the another pop element? E. From E to we have G, E, I, and we have found the element I, then we will return the same thing. So this is the working behind the ECLAT algorithm. Since ECLAT algorithm is an updation of a priori algorithm, so let's look at the advantages of ECLAT over a priori. The very first advantage is memory requirement. Since the ECLAT algorithm uses a depth-first search approach, it uses less memory than a priori algorithm. The second advantage is its speed. The ECLAT algorithm is typically faster than the a priori algorithm because of its search technique and the number of computations. When it comes to the number of computations, the ECLAT algorithm does not involve the repeated scanning of the data to compute the individual support values, and hence the number of computations are relatively very less compared to the a priori algorithm. Finally, now it's time for your favorite hands-on session on ECLAT algorithm in Python. So in today's hands-on session also, we are going to work on the same dataset that we have used in a priori algorithm. Let's quickly have a look at that dataset. See, this is the dataset which is having the transaction ID and the respective items in that particular transaction ID. At max, there were 20 items in a particular transaction ID. So like that, we are having a dataset of 7,501 records, which means we are having a transaction IDs of 7,500. Now, so in order, as we know that lists are easily mutable and helpful for our transaction, So I am converting my data set into a list. Further, firstly, I am creating an empty list. See, it has been successfully executed. Now that what I am doing is, firstly, I am converting the whole data set values into two lists. And that from data set values, after creating the list of the data set, I'm transferring it into sublist variable. And further, out of sublist, we are having all the items in particular single list. So what I am doing, I am separating each and every item of the particular sublist into an item and then storing this item into a newly created sublist. Like that. After that, I am appending the same sublist into transaction. So what I am doing, let me just execute this chunk of code, then you will get an idea what I was saying. See, it has been successfully executed. Now you can have a look at it. See, this was what we have done. We have just separated all the particular items and stored them in a list as shown in this figure. See, we are also having this list, this transaction ID is containing 20 items. So at max there were 20 items as I have already said in the earlier. Okay. After converting it into a list, what I am doing is I want to convert the whole dataset into an encoded form where I would just want to represent whether the item is present in terms of true or false. If it is present, then I will mention it as true, or else it is false in the transaction ID. For that, what I am doing is from MLX10, I am using pre-processing and importing transaction encoder class and created an object of transaction encoder class. Let me execute this chunk of code. See, it has been successfully executed. After that, I am fitting and transforming the transaction list and converting it into a binary data form, and I want to again convert that into a data frame because in MLX10 and after using a priori we have to pass a data set to the a priori algorithm. We will come to that step by step. Let's first execute this chunk of code so that you can have a clear idea what I was saying. See, it has been successfully executed. See, firstly, that is TE binary. Let me show you that thing. See, it's an array of true or false. If that particular item is present, then I'm stating as true, else everything is false. See, as we done for all the records. After that, I'm converting this array into a data frame, and that is in df1. Let me show you that also. See, it has been successfully executed. I'm preserving the column names. That's why I have mentioned here columns is equal to true. See. Okay. After converting it into a data frame, just we have to train through a priori algorithm first, then we have to apply ECLAT algorithm. For that, what I'm doing from MLX10 and using frequent patterns and imported a priori and the association rules and created a variable, a object df set in which I'm calling the constructor of a priori and passing it df1, and I have mentioned the minimum support and I want to preserve the column name. Just let me execute this chunk of code. See, it has been successfully executed. After applying the a priori algorithm, I'm using the ECLAT algorithm. For that, I'm applying the association rule and passing it the data df sets that we have created just now using a priori algorithm. And then I'm using only metric as support. You can use lift and confidence also, but if you want to use ECLAT, then you have to mention only support. And I have mentioned the same minimum support threshold value and also support only as true. Then I would like to execute this chunk of code and let me show you what I have done now. So after this, we are getting something like this. Yeah. See, it has been successfully executed, and you can see, you can suggest the store manager that these are the items that should not be out of stock at any time because they have interestingness among themselves. You can have a look of all the records. From this, the store manager can get an idea that these are the items that are having interestingness and dependent on each other. Like this, he can have more sales, and you can suggest this as a data scientist. Thank you. So, as usual, I have included code snippet for your fast revision. So you can pause your video right here and can take the screenshot of the same for your future reference. I hope this video proved fruitful to you and hope you have gained something extra than what you were knowing earlier. Thank you.